Hello everyone, welcome to the video on segment tree by Intellipaat. Today we are going to cover advanced DSA concept known as segment tree. If you ever go for interview to top MNCs such as Google, Amazon, Meta for developer interviews, you could land a problem on this concept. And that is why today we are going to decode what this concept is all about. We will understand what is segment tree, how does it work, and its simple programming implementation using C++ language. But before we begin, make sure to subscribe our Intellipaat YouTube channel to never miss any update from us.
We will start by understanding the needs of the segment tree. Let's take an example of returning and updating a sum of sub-array of size m. Here, the sub-array means the continuous part of the array. Let me explain this with an example. Suppose we have an array of size 7, which contains the elements 3, 5, 1, 4, 8, 6, and 7, and the indices are 0, 1, 2, 3, 4, 5, and 6. Generally, in segment tree, we perform operations such as query and update. The query operation involves retrieving information from an array such as finding a sum, minimum, maximum, or the average over a given range. For example, suppose from this array we want to find the sum of elements ranging from the index 2 to 5. For this, the very basic approach we can think is to iterate from I is equal to 2 to I is equal to 5 and calculate the sum. And we will return the sum as output. But can you think of the time complexity for this approach? It will be the order of n. And if we get the query for the update, then what we'll do? But before that, let me clear you guys what actually update means in terms of segment tree. See, the update operation means to modify the value of a specific element in the array and adjust the segment tree accordingly. So in this case, it is very easy. Like you just have to modify the element at index I with a new value. Here we can see that from this approach, the time complexity for the query is order of n and for the update it is order of 1. Now we will see another approach for the same query and update. And the second approach is prefix sum approach. So, what is prefix sum? So, to find the prefix sum, what we will do is at index 0, keep the element as it is. Then we will add the element at index 0 and 1 which is equal to 8. Moving forward, we will add n plus 1 is equal to 9, 9 plus 4 is equal to 13, 13 plus 8 is equal to 21, 21 plus 6 is equal to 27, 27 plus 7 is equal to 34. So this becomes our prefix sum array. So here we can see that the prefix sum array contains the elements 3, 8, 9, 13, 21, 27 and 34. If we have to find the sum of elements between the index I is equal to 1 and I is equal to 5, then simply subtract the element at index I minus 1 from the element at index 5. So, in general, you can remember sum is equal to prefix at index j minus prefix at index I minus 1. If I is not equal to 0, but in case if I is equal to 0, then sum is equal to prefix at index j. So, what do you think is the time complexity for this approach? It is the order of 1. So, let's see for the update using this method. What do you think? Can we directly update as we did in the previous approach? I guess no, because we have the given array which contains the elements 3, 5, 1, 4, 8, 6 and 7. But in the prefix sum array, we have the elements 3, 8, 9, 13, 21, 27 and 34. So, if you want to update at index I is equal to 3, then the element from I is equal to 3 to index I is equal to 6 will get affected. The element in the prefix sum array become I is equal to 3 will remain the same, but the element after I is equal to 3, that is 21, 27 and 34 will get changed. So in this case, the time complexity for update will be order of 1. Now, in approach 1, the time complexity for query is order of n and for update it is order of 1. Similarly, for approach 2, the time complexity for query is order of 1 and for update it is order of n. But for the segment tree, the time complexity for the query is order of log n and for update it is also the order of log n. See guys, the log n is much faster than m. Remember this. So if you want to optimize the time complexity for both the operation, then we will use the segment trees. Let us see how to construct a segment tree of a given array. Suppose we have an array which contains the elements 3, 5, 1, 4, 8, 6, 7 and 9. So, we will divide the above arrays. So, in our array, we will divide it into two parts. One part contains 3, 5, 1, 4 and the other part contains 8, 6, 7, 9. Now, we will divide further into two parts of each like 3, 5 and 1 and 4. From the left and from the right, we will divide 3 and 5 and 1 and 4. We will again divide further like 3 and 5 and 1 and 4. Similarly, we will do for the right part. We will divide in similar fashion. So this is what we get after the segment tree. So this is the construction of segment tree. Now moving forward, now we will see the number of nodes. What does this mean? This means how many nodes we got. We will calculate by seeing the last node which is n. Just above that it is n by 2, following above it is n by 4 and so on till 2 plus 1. Here we can observe that it is in GP, and after observing we can see that the common ratio is 2. Now, here the number of term bx. So we are letting the number of term be x and using the formula of GP of sum a r to the power x minus 1 is equal to n. Now here we are taking the value of a is equal to 1 and r is equal to 2. Now putting the value we will get 2 x minus 1 is equal to n. Now taking the log both sides, and here we are taking the log of base 2. So it becomes log of 2 to the power x minus 1 is equal to log of n. After solving, we will get x is equal to 1 plus log n. So this is the height of segment tree. And here the number of nodes is equal to the sum of GP. So after solving, we will get the number of nodes is equal to 2n minus 1. If the number of elements are odd, then the level of nodes and the number of nodes get increased. So for safety, we make the segment tree of size 4n size. Now moving forward, we will see the structure of segment tree construction, as we have already seen how segment tree are constructed and represented. In our example, we wanted to find the sum. So the very first node is called the root node and represent the sum of the whole array. So here the 43 is representing the sum of the whole array, that is from the index 0 to 7. Now moving forward. Now after that, for the index 0 to 3, the sum is 13, and for the index 4 to 7, the sum is 13. Now moving forward, we can see for the index 0 to 1, the sum is 8, and for the index 2 to 3, the sum is 5. For the right hand side, we can see for the index 4 to 5, the sum is 14, and for the index 6 to 7, the sum is 16. Similarly, we can see the rest. So this is how the segment tree construction works. Now moving forward, we will see the implementation for the same. So let's do that. The very first thing we will do, we will create a class named segment tree. So let's do that. Segment tree. Now we will make it public, like public. This indicates that whatever the member we will initialize or declare here can be accessed outside the class. Now, we will create a constructor which takes the vector of integer array as an input. So let's do that. Segment tree const vector in yeah. Now, we need to set the size of the array. So let's do that. N is equal to AR dot size. Now, to resize the tree vector to accommodate both leaf and internal rows of segment tree, for that we will simply do tree dot resize to into n. Now we will call the build method to construct the segment tree based on the input array. So let's do that. Build array. Here we haven't mentioned the class, we just have written the segment, so let's correct that. Now moving forward, we will create a function named query to find the sum of a given range which takes two integers L and R as a parameter. So let's do that. Int query int L and int R. Here L and R represents the range and return the integer result. After that, we need to adjust the left and right boundary index for the segment tree representation. So let's do that. L plus is equal to M. Similarly, R plus is equal to M. Now we will declare a variable named result to store the output. So let's do that. Int result, and we will initialize it to 0. Now for traversing through the segment tree, we use a while loop with a condition L should be less than or equal to R. So let's do that. While L should be less than equal to R, now if L modulus 2 is equal to 1, it means it checks L is the right child of its parent. Then we need to add the value at the right child to the result. So let's do that. Result plus is equal to tree of L. Now to move the next right child, we will simply do L++. So let's do that. L++. Similarly, we will do for the right child. So let's do that. If R modulus 2 is equal to 0, then result is equal to tree of, and we will simply do R minus minus. To move up to the parent level, simply do L is equal to L by 2 and R is equal to R by 2. So let's do that. L similarly R now we will return the result. So return result. Now we will write a function for the update which takes two integer index and value as a parameter. So let's do that. Void update int index into value. Now to adjust the index of segment tree representation, we will do index plus is equal to M. So let's do that. Index plus is equal to M. Now to update the value of a specified element in the segment tree, we will do target index is equal to value. That is tree index is equal to value. Now using a while loop to propagate upward in the segment tree. So let's do that. While index is greater than 1, index is equal to 2. Now we need to update the parent's value based on the updated child value. So let's do that. Tree index is equal to tree to index plus tree to index plus 1. Now we will create the segment tree. So let's do that. Private this private means we cannot access the member outside the class. So int n is equal to. So this indicates the representation of the size of the array. Also, we need vector int tree. This represents the vector tree. Now we will create a function named build which takes the vector integer array as a parameter. So let's do that. Void build const vector int ar. Now we will create two for loops. So let's do that. For int I is equal to 0, I should be less than n and I plus plus. Also tree of I is equal to tree of n plus 1 is equal to array of I. And the second for loop for in I is equal to n minus 1, I should be greater than 0, I minus minus. Then tree of index is equal to tree 2 into I plus tree 2 into I plus 1. Here the first loop initializes the leaf node of the segment tree with the value to form the input array, and the second loop calculate the values for the internal nodes of the segment by summing the values of their children. Now, coming to the main function, we can see that we have the array which contains the elements 1, 3, 5, 7, 9 and 11, and we are calling the segment tree function. After that, we want to find a query of sum on a particular range, that is 2 to 4, and also we want to update the value at index 3 by 8. Now we will execute the code and see the output. Here we can see that the sum in range of 2 to 4 is 21, and after the update, we can see that the sum in range of 2 to 4 is 22. That's all we got in this particular video. I hope this video helped you guys. So if you like this, then don't forget to hit the like and the subscribe button to our Intellipaat YouTube channel to never miss any updates from us.
Just a quick info guys, Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards a career growth with the full stack developer course.